From the apps on your phone to the massive systems that power, well, our entire economy, software is absolutely everywhere. But have you ever stopped to think about how it's actually built? It's not just about a lone genius writing code in a dark room. It's about engineering. And today, we're going to pull back the curtain on the blueprint for our entire digital world. So let's start with a question. Why is building an app like building a skyscraper? I mean, think about it. You wouldn't just start stacking steel beams and hoping for the best, right? Of course not. You need a detailed plan and architectural blueprint. Well, it's the exact same idea for software. You need a solid, structured process to make sure the whole thing doesn't come crashing down.
All right, here's our game plan for today. We're going to start with the early days, the chaos before the craft. Then we'll look at the blueprint that brought order to it all. We'll explore two totally different ways to follow that plan, see what happens when things go wrong, and finally, take a look at how this field is literally engineering our future.
Okay, let's dive into part one, from chaos to craft. Because believe it or not, building software wasn't always this structured, disciplined thing it is today. In the beginning, it was a bit of a mess. Yeah, back in the late 1960s, the world suddenly needed huge, complex software systems. The problem was, the methods for building them just couldn't keep up. It got so bad that people started calling it the software crisis. We're talking massive, super important projects that were constantly late, wildly over budget, and a lot of them just failed completely. It was pretty clear something had to change, and fast. And that big change was the birth of software engineering as a real formal discipline. This official definition really nails it. The keywords you need to hear are systematic, disciplined, and quantifiable. See, it wasn't just about pure creativity anymore. It was about applying serious engineering principles to the art of making software. And that leads to this really crucial distinction. Programming can be a solo act, right? One person writing a piece of code to do one thing. But software engineering, that's a team sport. It's all about building enormous, complex systems that are going to be worked on and updated for years by tons of different people. It brings the structure needed for that kind of collaboration and long-term survival. So, how did they fix the crisis? Well, engineers came up with a kind of universal roadmap, a blueprint that any team could follow to build good software. We know it today as the Software Development Lifecycle, or SDLC for short. The SDLC is really the beating heart of software engineering. It takes this huge, intimidating task of building software and breaks it down into a series of clear, manageable stages. It's the step-by-step instruction manual for our digital skyscraper, making sure nothing gets missed along the way. Let's just walk through these stages real quick. You start with planning, figuring out the goals and if it's even possible. Then you gather requirements from everybody involved. After that, you design the architectural blueprint. Implementation, that's the fun part where the actual coding happens. Then comes testing, which is so important for squashing bugs. Deployment is getting it out to the users. And finally, maintenance is the never-ending job of updating and supporting it. Which brings us to section 3, 2 paths to build. See, just because everyone has the same blueprint, the SDLC, it doesn't mean they all follow it the same way. There are actually different philosophies, different methodologies for how you move through those stages. And the two most famous approaches are, well, they're practically polar opposites. One is super rigid and linear, while the other is all about being flexible and cyclical. And choosing between them has huge consequences for any project. So, on one side, you have the classic waterfall model. It's sequential. You have to finish one stage completely before you can even think about starting the next. It really only works when you know exactly what you need from day one. Then, on the other side, you have the modern agile model. It's all about working in small, rapid cycles. Requirements can change, testing is happening all the time, and you're constantly delivering small, working pieces of the software. This was a revolution. It changed entire company cultures, creating this constant feedback loop with customers and really pushing for intense collaboration. That rigidity is the defining feature of the waterfall model. I mean, you do all your planning, then you finalize all the requirements, then you design the entire system, and on and on. There's no going back. And if you find a major problem during the testing phase, oh boy, it can be incredibly difficult and crazy expensive to fix because you have to swim all the way back up that waterfall. So let's talk about why all this planning matters so much. Because the consequences of ignoring these engineering principles, well, they can be absolutely catastrophic. What really happens when you try to build that skyscraper without a blueprint? When you just jump in and start coding without a systematic approach, the results are predictable, and they are not pretty.
You wind up with software that's just full of bugs and crashing all the time. Your project drags on forever and costs way more than anyone planned. The code itself becomes this tangled nightmare that developers call spaghetti code, which makes it almost impossible to update. You open yourself up to huge security risks, you create a terrible user experience, and honestly, you just dramatically increase the odds of the whole project failing completely.
But when you stick to the blueprint, you get the complete opposite. This is the payoff. Software engineering gives you the structure you need to build reliable software. It helps you manage complexity, which in turn brings down costs and the time it takes to build. It's really all about building it right the first time. And that brings us to our final section, engineering the future. Because this discipline is anything but static. It's constantly evolving to tackle the next wave of technological challenges. Yeah, the blueprints of today look totally different from the ones used in the past. Modern software engineering has to weave in these massive new trends, things like artificial intelligence, the whole DevOps culture for getting things out the door faster, and building apps specifically to live in the cloud.
So here are the big trends you need to know about. DevOps is all about breaking down the walls between the people who build the software and the people who run it, so you can release updates way faster. Cloud-native development means designing your apps from the ground up to take full advantage of the cloud's power. Engineers are also now building and maintaining these incredibly complex AI systems. And finally, cybersecurity isn't an afterthought anymore. It's a critical piece that has to be baked in from the very beginning.
And to really get your head around the scale here, just listen to this quote. The economies of all developed nations are dependent on software. That is not an exaggeration. From banking and healthcare to, well, everything. Software engineering is the foundation that makes our modern world run. The stakes have truly never been higher. Which leaves us with one last big question. Software isn't just a tool we use anymore. It is actively building our reality. So as it gets woven even deeper into our lives, who are going to be the architects of tomorrow? Who will be responsible for engineering the next blueprint for a world that's literally built on code?